5-minute quiz. A microscope that can see under the tissue is something microscope. This video is presented by Center for Molecular Spectroscopy and Dynamics, IBS, at Korea University. We've all been in a car at some point looking outside through the window. The water vapor in the fog makes objects blurry or invisible, and objects seen through water droplets on the window look distorted. These wavefront distortions are largely classified into aberrations and scattering. As light passes through a non-uniform medium, the wavefront of light is distorted due to collision with the medium. This phenomenon is called aberration. Also, randomly scattered light from the medium leaves the image as background noise. Therefore, if aberration and scattering can be reduced, clear images can be taken. Imaging the inside of living tissue with a microscope, such as skin, is similar. The skin tissue is very turbid and is densely composed of various substances. Therefore, the deeper the light propagates into the skin tissue, the more severe the aberration and scattering becomes. So, can a conventional microscope be able to image living tissue through the skull of a mouse? Mouse skulls show very severe scattering and aberrations, so if you take a picture through the skull with a regular light microscope, you won't be able to see anything like the image in the middle. If you want to take a clear myelination image of neurons as shown in the image on the right, you have to remove the skull and take a picture with a conventional microscope. A microscope designed to compensate for image degradation caused by aberration and scattering is the reflection matrix microscope. Using a pulse laser, a reflection image can be taken with a camera, aberrations can be loaded on the wavefront of light with an SLM device, and a fluorescent signal can be imaged through a PMT device. Reflection image can be acquired through a point scanning with a focused laser beam. As the light enters the object, the focused light gradually spreads by the point spread function. The reflection images spread by the point spread function are measured with a camera through the interferometer. Each of an amplitude image and a phase image of the reflection image can be obtained by the interference, respectively. In this way, reflection matrix images taken through point scanning are reconstructed into a reflection matrix. Then, the scattering noise can be reduced through recombination to increase the resolution of the image. After that, we move on to the step of applying the class algorithm that corrects aberrations. Aberration correction image reconstruction process through class algorithm. Compared to an image without aberration correction, the image with aberration correction becomes sharper as the algorithm progresses. The aberration when the wavefront of light enters the object from the outside and the aberration when the light goes out from the inside of the object can be calibrated separately. By compensating the aberration obtained in this way on the distorted object image, a clear image can be obtained. If normal plane light is incident on the skin tissue, distortion will be severe due to aberration and scattering from the tissue. However, if the complex light wavefront composed of inverse aberrations is incident on the skin tissue with the aberration found in the reflected image, it is accurately focused on the target to be imaged, and a fluorescence image without distortion can be measured. Aberration-corrected images were visually displayed using a Siemens star resolution measurement target. Compared to the image without aberration correction, it can be seen that the image on the right, in which the aberration has been directly corrected with the SLM device, looks much clearer than the image on the left without correction of aberration. It can also be seen that the point spread function is much smaller when the aberration is corrected directly with the SLM device than the point spread function in the absence of aberration correction. This technique was applied to the imaging of neuronal dendrites through the skull of a mouse through the SLM device. When the aberrations were not corrected with the SLM device, no neuron myelination was seen in the reflection image, and it was confirmed that the neuronal myelin was not clearly visible in the fluorescence image. However, when the aberration was corrected with the SLM device, it was confirmed that clear myelination of neurons was visible in both the reflected image and the fluorescent image. 5-minute quiz. A microscope that can see under the tissue is something microscope. The answer is reflection matrix microscope. Lastly, if you found this video interesting and useful, please like and subscribe. Thank you for watching the video. This video is presented by Center for Molecular Spectroscopy and Dynamics, IBS, at Korea University.